So we're going to start in chapter 7, and that might seem a little odd, but this is probably one of the most practical chapters in the book. And I'm going to bring in everything we need from chapters 1, 2, and 3 as we need it, rather than doing a big long review that you don't know why we're doing it. So then chapter 4 will be logarithmic and exponential functions that we'll review when we need those. Chapter 5 is the mathematics of finance, so I'm saving that till last since most students find that a little less rigorous than some of the other parts of the class. Then we skip chapter 6, so here we are at chapter 7. So we're going to be working our way up to linear programming in section 7.3. That's kind of the culmination of the putting everything together to actually do linear programming. But before we can do that, we have some skills that we need to develop and make sure are robust before we go on to putting the whole thing together. So in each section, I have the objectives listed that hopefully at the end of the section, you can come back here and say, do I know how to identify a linear inequality into variables? Check. Do I know how to match an inequality with its graph? Check. And make sure that you do know how to do all the things that are listed in the objectives. So I like to give an overview because I'm the kind of student that I want to know, why are we doing this? So linear programming is actually a really helpful tool that businesses would really use. It would be much more complex in an actual business situation. We simplify it and look at a much smaller type of problem that hopefully you'll be able to see how it could be extended to a much larger problem and be used in the real world. So we're going to be looking at simpler problems like a chainsaw requires 4 hours to assemble and a wood chipper needs 6 hours to assemble. You have one person who can work for 48 hours and you make $150 profit on a chainsaw and $220 on a chipper. So the question is, how many of each should be assembled for maximum profit? So it could be that you could just reason this out and kind of solve the puzzle some other way besides linear programming, but we're using simpler problems to explore the method, which would then get extended to more complicated problems. So each business usually has limitations on either the amount of time they have or how much space or how many employees or how much money. And so all those things get taken into consideration in a linear programming problem. So the first thing we're going to do is learn how to identify a linear inequality into variables. So remember the 4 inequality symbols: greater than, less than, greater than or equal to, less than or equal to. So those are the linear inequalities. So the 2 variables we usually use are x and y. Occasionally t gets used for time, and you can actually name the variables whatever you like, but I find that most students are most comfortable using x and y. So in order for an inequality to be linear, to meet the definition of linear, we look for something that looks like y and mx plus b. So hopefully that looks vaguely familiar from when you learned about lines. And then you would have one of the inequality symbols between the y and the mx plus b. When there's an equals there, we're talking about a straight line. And then when we put an inequality, we're going to talk more about what does that mean and how does the graph look. So the things to look for are x and y have no exponents. The x and the y are not multiplied together. So inequality has to fit this model in order to be a linear inequality in 2 variables. So for example, we could have y is bigger than 2x minus 3. So then remember that the m is the 2 and the b would be the negative 3. and this is a linear inequality in two variables. Well, it doesn't have to necessarily look exactly like that. It could look like 2x plus 3y is less than 6. Well, if you can rewrite it so it looks like this form, then it's still a linear inequality in two variables. So hopefully you recall that you could do some algebra here and solve for the y. So we could subtract 2x from both sides, and I'm going to work horizontally since I'm out of space. So then I'd have 3y is less than negative 2x plus 6. And then I would divide both sides by 3 and have y is less than negative 2/3 x plus 2. And I can see that the m is negative 2/3 and the b is 2. So this fits the model. It matches this formula. So even though it looked like the red writing to start with, because we can rewrite it in that form, it meets the definition. So we need to be able to recognize those. That's all we're doing in Chapter 7 is working with linear equations. Okay, then we need to be able to make graphs of the inequalities and be able to recognize a graph of an inequality. So the first part of graphing a linear inequality is to graph the line that you get when you replace the inequality with an equals. So for example, if I put y equals negative 2/3 x plus 2, that's the graph I would start with to graph this inequality. So I would use the slope-intercept method, and we'll review that. Once that line is graphed, then you need to indicate which half of the plane. So when we draw a graph and we label the horizontal axis x and the vertical axis y, we're indicating that we're talking about the xy plane that goes infinitely in every direction. And so when you graph a line on it, then to graph the inequality, you have to say which side of the line are where the solutions are. So let's talk about how you decide where to shade. So there's two methods, the pick a point and test it method, and then the other method is the above below method. Either way is totally fine with me. I would suggest that you pick one and practice it until you get really good at it so that you'll be really comfortable with it when it comes to a quiz or test. So the first method is the pick a point and test it. So 0, 0 is the easiest one to choose. So I'm going to go ahead and stick with this example of y is less than negative 2/3 x plus 2. And if I plug in 0, 0, I want to see if I get a true statement or not. So I want you to tell me what you're doing and then do it. So tell me I'm testing 0, 0. So you put a 0 where the y is, a 0 where the x is, and then you're asking this as a question. You're saying, is this true? So that would be like asking the question, is 0 less than 2? Which is true. So you should shade where 0, 0 is. If the point you pick makes the inequality false, then you shade away from that point. So I need to either see math work or a verbal explanation of your reasoning for how you decided where to shade. Okay, so let's look at this example. And the inequality didn't show up on the page here. So we're graphing the inequality y is greater than x plus 2. Okay, so the first thing we do is put an equals and graph that. Well, the y-intercept is 2. The slope, we don't see anything here, so the slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. And then you need to use a ruler or some kind of a straight edge to draw really, really straight lines, because it's going to matter later when we're looking for the intersections of two lines. If they're not both precise, you won't be able to find the intersection. So then I'm going to choose the point 0, 0 and see if that makes my inequality true or false. So I put 0 for y, and I say, is that greater than 0 plus 2? Well, what do you think? Is 0 greater than 2? I don't think so. So we'd say it's false. So we shade away from 0, 0. So if you learned shading, that's fine, but I think you'll find for what we're doing in this class that it actually works better to use arrows to indicate which side of the line we're choosing, because we're going to have 3 and 4 inequalities all on the same graph. And if you start shading, it gets just kind of all dark and really hard to tell what's going on. Whereas if you have the arrows, it's a little clearer. Okay, so that's an example of the pick a point and test it. So the other way you can use is the above-below method. So if you have the inequality y is less than or equal to x plus 2, think about the xy plane, and you find smaller values of y below. So if you read this math sentence that is the inequality as I want y values that are smaller than the ones on x plus 2, that means you want the ones below the line. So that's all you have to write is I want y values that are below. So you would graph the line and you would shade or use arrows to indicate below the line is where we would find solutions. So if the inequality was y is greater than or equal to x minus 3, you want y values that are larger than x minus 3, and you find those higher on the grid, so you can just write above and then shade above. So if you prefer this method, when the equation is given